chapter 4 and lecture 18. Okay, so example we'll do today in today's lecture. This is very important concept. Okay, this part is very important, so please be focused on this part. So let f is equal to r. Now take L is equal to R3. Now I will be taking R3, 3-dimensional, right? So for x is equal to x1, x2, x3 and y is equal to y1, y2, y3, I have defined x cap y is equal to x2 into y3 minus x3 into y2, comma x3 into y1 minus x1 into y3, comma x1 into y2 minus x2 into y1. Okay, so this is how I define my x cap y. First, what I have done over here is this part is what? x2 into y3. Okay, x2 into y3, x2 into y3 here. This into this minus x3 into y2 here. x3 into y2, comma x3 into y1 here, this x3 and this y1 minus x1 into y3 here, comma x1 into y2 now and x2 into y1 over here. Okay, I'll turn the page. Now vector product x of x comma y tending to x cap y defines the structure of Lie algebra on L. We denote this Lie algebra by R cap 3. Okay, so how we define the structure of the Lie algebra? Like this, R3 of cap. Okay, next is the exercise 1.2. Now this part is very important to solve. Exercise 1.2. Show that cap is a bilinear. Now I have to show that this is a bilinear. Now solution is here. Now to show that it is a bilinear, I have already given in the previous lecture that alpha x plus beta y comma z is equal to, now with the help of this I am going to prove that this is a bilinear. Okay, so alpha x plus beta y comma z is equal to alpha x plus beta y cap z. Okay, so it is like this term, it will be like x, and this term it's like y from here, x cap y. Okay, so now how I have to write this as alpha x1 plus, now this is equal to alpha x1 plus beta y1 comma alpha x2 plus beta y2 comma x3 alpha x3 plus beta y3. This I have written in this form because it is r cap 3, right? We have to write in this r3. So that's what I have done over here. And that's this cap, then this is what? z1, z2, z3. Now what I have to do is, now just look here, okay? x2 into y3. That means what I am supposed to do? I have to take these x2, okay, into this y3. This is like my weight, okay? I'll just make this as my x1, x2 and x3 just in the roughly, okay? And this is like my y1, y2, y3. Now what I'll do, here x2 into y3, x2 into y3. So here what I'm going to do is, where is my x2? This into this, x2 into y3 here. Okay, I'll do it on the next page. See, here what I have done over here is this part. As you know, x2 into y3. So this is my x2. This into y3 is what? z3, right? So This is my x2, this alpha x2 plus b beta y2 into z3 minus, which minus, you'll have to see the definition of this, then minus x3 into y2. Now here, where is my x3 here? This is x3 into y2 I have done over here. x3 into y2 is what? z2, no? In place of this. Next what I have is comma x3 y1. So x3 this into this. x3 into y1. And then minus from this, I have taken from the formula like this, I am applying. So minus what? This is again, which part you will have to take from here? Minus x1 into y3. So minus this into this z3, which I'll have to place it over here. Then comma, last part is what? x1 y2 x2 into x1 into y2 minus x2 into y1. Okay, so x2 into y1 is what? z1. And what is x2? Alpha x2 plus beta y2. That you have to place it over here. y1 into z2, then minus x2 into y1. No? From that formula, you'll just see from here and then do it, okay? And to make it easier, more easier, I have done it like this. And then you all will get this step. After this step, I will be doing one more step. I'll turn the page. I'll do it on the next page. Okay, now what you'll have to do over here is just take the alpha part separately, okay? And beta part. So wherever alpha, here also alpha is there, here also alpha. Now everywhere alpha is there, take it as common and take it outside, okay? Like here. So you'll have to take this alpha outside, then wherever there is in bracket, put bracket. Then wherever there is alpha value, like here alpha was there, right? x2 into z3. x2 into z3 minus, from where I got this minus x3 into z2. x3 into z2, comma, x3 into z1. x3 into z1 minus x1 into z3. x1 into z3 here, comma, then x1 into z2. x1 into z2 here. Next, x2 into z1 I already got, and plus. So here we are done, no? x2 into z1. Then plus beta part now. Beta take it common, okay? Wherever there is beta. So here what I got? y2 z3. See, y2 z3 minus y3 z2. y2 z3 minus y3 z2, comma, y3 z1. y3 z1 minus y1 z3. y3 z1 minus y1 z3, comma, y1 z2. So here it is y1 z2 beta, wherever there is beta, that only we are writing. So y1 z2 minus y2 z1 minus y2 z1. So we are done with this part. Now finally what we are going to get? This is equal to alpha, this alpha, and this is what? By the definition of x cap y, we get x cap z plus beta, this beta, y cap z, okay, by the definition of x cap z. So similarly, x cap alpha y plus beta z is what we can do is, for x cap alpha y plus beta z, for this one also you will have to do the same way how I told you all, and then I will get this alpha x cap y plus beta x cap z. This is my exercise 1.2 second one. Show that x cap into y cap z is equal to x into z y minus x into y z for all x comma y comma z belonging to R3, where x dot y denote the dot product of vectors x comma y belongs to R3. So I need to prove this now. I have to show that this is equal to this and this is equal to, okay, so this is equal to this, okay. So for that what I need to do is take the left hand side first, this left hand side, x cap, y cap, z. So this x cap I wrote it as it is, cap, what is y cap z? From the first proof I have already done this, y cap z what I got, write it here. So what I am going to get is y2 z3 minus y3 z2 comma y3 z1 minus y1 z3 comma y1 z2 minus y2 z1. Okay, and this x I can write it as what is my x, x1 x2 x3, right? That cap into this, I'll write it on the, I have written it on the next, I'll turn the page. Yeah, so this is equal to what? X is what? x1 x2 x3 cap into that what? This cap, this part I have written it over here. I hope you all can see this clearly. Next what I have done over here is, now x2 into this. Now what is my x2? Yeah, x2 into y1 z2 minus y1 z2 minus y2 z1. So this into this. Sorry, x2 into this, okay, x2 into this y1 z2 minus z2 z1 I have done, okay. Then minus x3 this into y3 z1, this into this I have done, then comma, put comma, then I have used the definition of x cap y, okay, that like now x3 into y2, so this into this, and next what I have to do is minus x1 into this, comma x1 into, then I have to do x1 into this, and then minus x2 into what? y2 z3, this, okay. Then put a bracket. Now this is equal to what? Now what you will have got? x2 y1 z2. Now multiply this, okay. Now we will have to multiply this. Now what you will have to do? Okay, I have already told you all that you all have to multiply this x2 on both the side of this, which I have already done now here. And then minus x3 you all have to multiply here also and here also, comma, put comma, then x3 again you all have, here x3 you all have to multiply with this, which I have already multiplied, then minus as it is, and this multiply with this also, and the last one is comma, put comma over here, and then do the last one, x1 y3 z1 minus x1 y1 z3 here, minus this into this into this, x2 y2 z3 plus minus and minus plus, no, x2 y3 z2. Next I'll turn the page for the left hand side, okay, this. Now I will be doing it for the right hand side. Take the right hand side of this. Now you will have to take the right hand side, this part. Now I have to take this right hand side Okay, and you know that x dot y, now this is denoted as the dot product of vectors in R3, right? So let us do this. Now right hand side of yours is equal to, take that whatever I told you, x into z. Now how I'm going to write this part as x1 into x1 z1 plus x2 z2 plus x3 z3 bracket, outside the bracket you will have to put y1 comma, now this in terms of r3 I have to write, right, this part only for this. Okay, then x1 z1 plus x2 z2 plus x3 z3 y2, then this is what in the bracket, this comma you'll have to put. Okay, and then x1 z1 plus x2 z2 plus x3 z3, outside the bracket you'll have to put y3 and put a bracket, then minus, this minus all have to put, then put again the bracket. Now this is what x1 y1, now this I will write it as what x1 y1 plus x2 y2 plus x3 y3 z1. Okay, so because of this z1 z2 z3, so in this part I am writing it as what x1 y1 plus x2 y2 plus x3 y3 z2 x1 comma x1 y1 plus x2 y2 plus x3 y3 into z3, put a bracket. Okay, now what I have done is I have taken this part, now this y1 multiply here inside for this one, and then minus, put a minus sign because here, because of this, and then put this part x1 y1 z1 minus x2 y2 z1 minus x3 y3 x3 y3 z1, this part. Okay, then put a comma, then take the next part, now take this part, multiply this inside, and then this is from where you have taken this part, minus this x2, sorry, x minus x1, this minus will be for this one also. Okay, so you all here, you all have to write it down, multiply this z2 inside also, and then write it here, x1 minus x1 y1 z2 minus x2 y2 z2 minus x3 y3 z2 here, put comma, then do it for the last part. Now for this one, multiply y3 on this sides, multiply this with this one, with this and with this, and write it here, then put minus because here for this minus is also for the third part, then write it down, x1 y1 z3 x1 y1 z3 plus x minus x2 y2 z3 minus x2 y2 z3 and minus x3 y3 z3 here, minus x3 y3 z3, and that minus sign is from here, this minus sign is for this one and this one. Okay, next I'll turn the page. So this is what from the previous page, and whatever is getting cancelled you have to cancel this. Okay, now x1 y1 z1 minus x1 y1 z1 is getting cancelled. Okay, here, then x2 y2 z2 x2 y2 z2 is getting cancelled, and here x3 y3 z3 minus x3 y3 z3 is getting cancelled, whatever is remaining write it here, and here what is getting cancelled, x3 y3 z3 and minus x3 y3 z3 from the previous page, this part is. Okay, so we don't want this page, you all see from here, what is remaining is your left hand side. Okay, tell you all, this part is from this page. Okay, from here, this page it is, and so with this I'm done with the second part. Now I have to prove that is Jacobi's identity. Okay, now here we have to check that the Jacobi identity holds in R3 cap. Okay, so for that what I need to do is, first So first I'll now to show Jacobi identity, what I'll do, so first I'll take the Jacobi's identity. I will write the Jacobi's identity like x, y, comma, z. First I have taken the Jacobi's identity x, bracket, early bracket of x, then lee bracket y, comma, z, then plus y, lee bracket of z, comma, x. This is also lee bracket, okay, plus this z into comma x, comma, y, okay. So first I have taken the Jacobi's identity. Then what I have done is, then what I have to do is, now this is equal to what? X cap, y cap, z. I have to write in this format. Plus y cap, z cap, x. Plus z cap, x cap, y, right? Now this I will write it how? Wait. Yeah. So this is equal to what? This x, then cap, in the bracket I will put y cap z plus y, then cap z cap x plus z cap this x cap y, okay. Now this I will write on the next page. Now this is equal to x dot z into y minus x dot y z, okay, then plus y dot, this is a dot product, right, z minus y dot z to x plus z dot y into x minus z dot x into y, okay. And now see whatever the terms are getting cancelled, like which term is getting cancelled now? X dot z or y, this, and which one? Minus x dot, terms are getting cancelled, and finally what I am going to get is 0. Okay. This I am done with today's lecture, and the next lecture will be on, I hope you all have understood this lecture. You all have to try to solve by yourself, and I hope you all have understood, and the next lecture will be on abelian, the definition of abelian, general linear algebra, and then I will be doing exercise 1.3, that is Jacobi's identity holds in GL of V. Thanks for watching.